Guys, welcome to this video on mathematics. I think the first question reads, rationalize the denominator of 3 plus root 5 over 2 minus root 5. Okay, so the solution, we are going to multiply by the conjugate of this one. So the conjugate of this is 2 plus root 5, both numerator and denominator. So and then when you do that, the numerator turns out to be 3 plus root 5. You multiply that with the new conjugate, and this gives us the quadratic expression. So we have that. Let's distribute that. We have 3 times 2, 6, 3 times root 5, 3 root 5 plus 2 root 5 plus root 5 times root 5, that's 5. Okay, so 6 plus 5, you get 11. Then 3 root 3 plus 2 root 5, that is 5 root 5. So that checks, that's the numerator. Now when it comes to denominator, we have difference of squares. So this is like, we have 2 minus root 5 and 2 plus root 5. The whole essence of multiplying by the conjugate is to eliminate the root or the surd or the radical. So we have 2 times 2, that's 4 minus root 5 square, that is 5. That gives us -1. So numerator over denominator, that gives me 11 plus root 5 times 5 over -1, and the whole thing now is -11 minus 5 root 5. That checks. Okay, I want to do another question here in number 3. You're told that a quantity q is partly constant and partly varies as the square root of s. Write down the law connecting q and s. Okay, so we have a quantity q that is partly constant, so we have the proportional sign, partly constant. Let me say my first constant to be k, and partly varies as the square root of s. Okay, so square root of s. So now to remove the proportional sign, we introduce the equal sign and then fix the necessary constants. So let me just put constant m. So here we are saying that both k and m are nothing but constants. Okay, so these are constants of proportionality. So that's the law connecting those ones. Then we are told if s is 16 when q is 24. So s is 16 when q is 24. So substituting these two into this equation here, so we have 24 equals to k plus m, and then square root of s, that is 16, so we can call this one 4m. Square root of 16 is 4. That becomes equation number 1. Remember, we must form simultaneous equations and then solve for the constants in question. So we have q is 32 when s is 36. Square root of 36, based on this law, we have 6m, and that becomes equation number 2. So we can solve these two equations simultaneously. So we have, this gives us 2m, and that is equal to 8. So m is nothing but 4. Okay, so we can use now either of these equations to determine k. So let's take the first one. So 24 equals to k plus 4 times 4, that is 16. So k is 24 minus 16. So k is 8. Okay, now because we already have m and k, we can write now the equation connecting with the relative constants involved. Okay, so we have q equals to k. This time we know k is 8 plus m is 8. m is 4, so we have 4 square root of s. So we need to understand the steps here. The first thing you need to do is to get this equation connecting, and you get it correct. Then with the two constants, we need to determine the value of those constants using the concept of simultaneous equations. Okay, all right, that's clear. So I want to use this application here to basically be able to follow my proceedings here. So I have a question here that was requested from the cohort I'm teaching, and the question involves, let's say you have a matrix with the following. So we have 4, 2, 3, and 1. And then you're told this matrix is M, so we call this one is M. And then you're told to determine the determinant of this and hence the inverse. Okay, so let's get the determinant. So determinant of M will be, so you multiply 4 and 1, then take away 3 times 2, so you have 4 minus 6, and this gives us minus 2. Now in order for us to get the inverse, having gotten the determinant, so we can say that now we know determinant of M equals to minus 2. So let's get the inverse of the matrix. So if the matrix is M, so the inverse of M is nothing but 1 over the determinant of that matrix, 1 over the determinant of M. Okay, so 1 over the determinant. So oops, I think we should do away with that and use the pen. So we have that. Then we have to interchange. A goes here, D moves up there, then the rest, B and C, acquire the negative sign. Okay, so that is what we do. We interchange that. All right, so let's go back to our previous matrix and do the inverse. Right, so the inverse now turns out to be, so we have M inverse will be equal to, so 1 over determinant, so determinant is negative 2, so we can call this one as minus 1 over 2. Then we have to write the adjoint there, so 4 goes down and 1 goes up, so we have 1, then 4 comes down here, then the rest of the elements in the minor diagonal acquire a different sign, so we have minus 2 and then we have minus 3, and that's how it is done. So thank you.